Two particles undergo SHM along parallel lines with the same time period and equal amplitudes. At a particular instant, one particle is at the extreme position while the other particle is at the main position. So they move in the same direction. We have to find out. They will cross each other after further time off. So we have two particles undergoing SHM in the two parallel lines, first particle and second particle. So while the first particle is at the extreme position, moving towards main position, the second particle is at the main position, moving towards negative extreme position. So after how much time they will cross each other? So we can solve this problem by using reference circle method here. So let me draw a circle here. So in this circle, first particle is at the extreme position over here and it is moving towards main position. That means if I consider a particle over here, the first particle is moving down along the circle. Now the second particle is starting from the main position and moving towards negative extreme position. If I take a particle like arrangement, so the particle will be at the down over here and moving along the circle like this upwards. Okay. Now first of all, if the second particle starting from here and first particle starting from here, first particle. I'm representing first particle by blue color, second particle by red color to understand easily. Okay, now as the first particle moves from here to here, it is moving from here to here. Clear? As the first particle reaches point to position 2, the second particle reaches this position over here. That means, so clearly we can see that in this position the two particles will not meet. Now as the second particle again moves up here, the first particle moves up along the circle over here. So if I draw a line bisector, means if I draw a line joining these two particles, now I can say that now along this axis, along this line, the two particles meet. Okay, so now let me find the angle here. So to find the angle, I am drawing a line from the center of the circle to blue and to red particle here. So let the angles made by these two vectors, two lines, with y-axis can be taken as here alpha. So here angle alpha and here also angle alpha only, same angle alpha and alpha. So now angle turned by first particle is, so angle made by or turned by, angle made by first particle is given by 90 degrees plus alpha, 90 plus alpha. Similarly, angle made by second particle is equal to, so if I imagine this angle as alpha here, so this angle is theta here also angle becomes theta only. So the second particle makes an angle 90 degrees plus again theta, 90 plus theta. So 90 plus theta. So both the angles are same here. That means I can equate these two. I'll get now. So 90 degrees plus alpha is equal to 90 degrees plus theta. So from this I can get alpha is equal to theta. So in the triangle we can say that if I replace alpha by theta here, so here I will get angle theta. So then clearly I can say that, so this angle 2 theta is equal to 90 degrees. So theta is equal to 45 degrees. That means now angle made by first particle is given by, so angle by first particle is given by, I can take angle formula as omega t. Omega t is equal to 90 degrees plus 45 degrees. So this is 135 degrees, which can be taken as 3 pi by 4. Now time taken. Omega t is equal to 3 pi by 4. So I can take omega value as 2 pi by capital T. 2 pi by capital T into small t is equal to 3 pi by 4. So here pi is cancelled. I'll get now small t is equal to 3t by 2 into 4, 8. 3t by 8 is the answer. That means for the first particle to reach from position 1 to this position, the angle rotated is given by 90 plus alpha, which is equal to angle is equal to again omega t. Angle is omega t. So we equated omega t is equal to 3 pi by 4 and we found the time taken here. So this is first method. And now we are solving the same problem by using method 2 now. Second method now. Okay, so imagine that in the diagram, imagine that the two particles are meeting over here, clear? So that means the first particle is starting from extreme position. So means I can write now for particle 1. For particle 1, I can take now x1 is equal to a cos omega t, and for second particle, for particle 2, I can take x2 is equal to minus a sin omega t. And both x1 x2 are equal here from the origin. So both x1 and x2 are equal because they are meeting at same point. So now after equating that, I will be getting a cos omega t is equal to minus a sin omega t. So a cancels here. I got now tan omega t. Tan omega t is equal to minus 1. That means omega t is equal to 135 degrees. Again 3 pi by 4. 3 pi by 4. Omega value is 2 pi by capital T into small t is equal to 3 pi by 4. So pi cancels. I'll get now t is equal to 3t by 8 is the answer.